section, we get to put everything together that we've done with logarithms and with exponentials in order to be able to solve equations. Now, whenever we say solve an equation, we're talking about finding out what the variable is. So, for instance, in this very first problem, we have log base 3 of x equals 4. Okay, in order to solve this, we need to figure out what is x. We're trying to get that all by itself. Now the problem here is that it's within this logarithm. So it's not like we can just, add something or divide something or whatever to get rid of it. This is the log base 3 of x. It cannot be broke apart. But we do have other options. And in this case, since the logarithm is not working for us, perhaps we want to try changing it over to exponential and see what happens. So let's take the base of 3 and we'll raise it to the other side, which is the exponent of 4, equals the argument, which in this case is x. Now we have changed the form, and this becomes a much, much easier equation to solve. So here we have 3 to the 4th power equals x. Well, what is 3 to the 4th power? That would be an 81. So we're saying that x equals 81. And now we do need to double check. See where it says verify your solution using a graphing utility? Well, we could do that. We would end up having to use change a base formula in order to do it. But what is much more important is that we check our answer to make sure that it is within the domain of the logarithm function. For instance, if you'll remember, our domain of logarithms was 0 to infinity. These are the only things that we can take the log of. We can't take the log of 0, and we can't take the log of anything negative. It has to be, starting at 0 but not including, all the way up to infinity. It has to be a positive number, basically. So whenever we put in our answer, we want to make sure that we're always taking the log of a positive number. Otherwise, our answer would be what we call extraneous. So in this case, if I took the 81 and plugged it back in, I would have log base 3 of 81 equals 4. Now, that is a true statement, and we could use the change of base and our calculator to figure out that that is equal to 4. But what's even more important than that is here I'm taking the log of a positive number, and that is okay to do. So our answer is a good answer. Let's try another one. Here we have one that says log base 5 of 2x plus 3 equals log base 5 of 3. Well, if you'll remember from a previous section, we had a rule that said if we have log base a of m equals log base a of n, then m equals n. The only way we can have logs identical to each other is if the arguments are actually equal to each other also. Well, in this case, our arguments are 2x plus 3 and 3. In order for both sides to be the exact same, then these arguments must be the same also. So 2x plus 3 must be 3. And now we can solve this equation. If we subtract 3 from both sides, we get 2x equals 0. And then dividing both sides by 2, we get x equals 0. Now this is our potential answer. We just need to make sure that it will work. If I were to go back and plug in a 0 in place of x, this would be 2 times 0 is 0, plus 3 is, in fact, 3. I can take the log of 3, and it is equal to the log of 3. So this is a perfectly fine answer.